Okay, part two, domain and range. This is a little dry. Once again, you have my notes, but I'm just going to get this on the board. So, domain and range. So, the domain is all possible values of the independent variable. All possible variables of the independent variable, generally like the x, t for time, and the last problem, number of people, and then the range is all possible values of the dependent variable, like the y values. So once again, we know it as x, or maybe t, and this is generally the y, like h of t or something like that. So, and then the other thing we need to think about is discrete data. So discrete data, how do we graph this? This is graphed as separate, distinct points. So for example, once again, you're just given a set of points. That's the idea of discrete, something that you can count, versus continuous data, which we're going to see graphed as lines or curves. Graphed as lines or curves. Okay, so how do we represent the domain and range? So representation, we can either use inequalities, or interval notations. So let's just go through these. Once again, this is really dry, but it's like how we write these things. So for example, with interval notation, we're going to see the bracket facing right. That means whatever's included. And then if we see a parentheses or a backwards bracket, that means excluded. Also, infinity is never included. Okay, so what we're going to do is we're going to do inequalities, and then over here we're going to use interval notation. As I said before, either you know this or... So first example, x is less than 3. As an inequality, we'd say x is less than 3. Using interval notation, we're going to say either open bracket negative infinity, comma, 3, or backwards bracket negative infinity, comma, 3, close parentheses. In both of these cases, neither of the limits are included, and because of infinity, we use a parentheses. Next, x is less than or equal to 3. Well, as an inequality, x is less than or equal to 3. Interval notation, well, negative infinity, because we're keep going to the left, but this time the 3 is included. Or backwards bracket, negative infinity, 3, close bracket. open, close. Once again, either way is fine. Next, x is greater than 4. Greater than 4. Well, with an inequality, we know x is greater than 4. Interval notation, well, we're starting at 4, but we're not including it, and we're going to infinity, and we're not including it. Or you might see backward bracket 4, infinity, backwards bracket. This is weird. I like this better. I like this even better. The last column before let's see, x is greater than or equal to 4, and then same thing, bracket 4, comma, infinity. Let's continue. X is between 1 and 5. Let's see. X is between 1. Let's see, what is it? -1 and 5. Okay, well, as a, can you see me? Oh, yeah, it's over there. Let's see, as an inequality, it's -1 between x and 5. It has, yeah. And then, or -1, comma, 5. Or backwards -1, comma, 5, backwards negative. So you might say, Mr. Eller, well, how do we know that it's included or not? Well, you're going to look for the word inclusive. X is between -1 and 5, comma, inclusive. When you see the word inclusive, you know that it's either -1 is less than or equal to x is less than or equal to 5. In interval notation, bracket -1, comma, 5, close bracket. Once again, yes, it's included in the set. You can visually see that. Next, all real numbers. X is all real numbers. Well, in this case, we're not going to write a bunch of infinities. We're going to simply write x is an element of the reals. That's every single number we've worked on since math. The integers, 0, negative, fractions, decimals, irrational, everything. X can be everything. And just a little things, just a couple of things. N is natural numbers. That's 0, 1, 2, 3, 4. You might see integers. You might see positive integers. And the last thing you might see is something called the rationals. Okay, let's move on. And then there's a couple of examples. So, and so on the lesson, I might say, x is from 3 to -3 to 8, inclusive. Pause and do this one. Okay, so it's -3 is less than or equal to 8x, x, or close bracket, comma, 8. Let's try another one. Y is greater than or equal to 9. Pause the video, take a second. Okay, well, we know that y is greater than or equal to 9, or 9, because 9 is included, comma, infinity. I'm not a big fan of the backward bracket. Included, excluded. I'm not going to use, henceforth, I'm not using the backward bracket anymore. How about 8 is less than -6? Well, that's easy. Pause. Okay, we're back. A is less than -6, or once again, 6 is not included, and everything is less than that. Now it's interesting. So this is an upper bound, and 9 is a lower bound. X is all rational numbers. If you recall, X is an element of Q. Okay. Now, sometimes we're not looking at. Sometimes we have, if we're looking at discrete. So let's take a look at discrete examples. Let's take a look at some discrete. So you'll be asked to find the domain and the range. So if I give you a table, let's start with a table. And the table has, let's see, it's 2, 5, 7, 8. And the range is 3, 1, 5, 6. What we're going to do is, let's see, the domain is, let's see, 2, 5, 7, 8. What's the range? What do you think the range is? Well, so you're looking and say, well, it's those y values. What we're going to do is we're going to put it in ascending order. So we're going to write 1, 3, 5, 6. Ascending order. Good. Let's move on. Another thing you might see is with the mapping, you know, the ovals. Let's take something like that. So let's see, we have -3, -2, 5, and 7. And in the other oval, let's see, that -3 goes to 4, -2 goes to 8, 5 goes to 6, and 7 also goes to 4. So the question is, what is the domain? What is the range? Well, the domain, we're going to say, is -3, -2, 5, and 7. Remember, it's just a set. So we need things to go inside the set. Now, what's the range? The range is simply, well, some of you might say, well, you know what? It's 4, 4, 6, 8, but we don't have to repeat elements of the set. So we're going to write 4, 6, and 8. No need to repeat. No need to repeat. Okay, nice. Let's move on. You might get a set of ordered pairs. Once again, very set of ordered pairs. So, for example, if the set was, let's see, -3, 5, -1, 9, and let's make it 3, 5. What's the domain? The domain is -3, -1, 3. Once again, going ascending order. What's the range? Well, the range is, we have 5, 9, 5. No need to repeat 5 and 9. The last thing we want to look at, well, this is discrete. Let's look at something continuous. So, for example, continuous, how about we look at like y equals 2x plus 1. So we're going to start to look at equations. So we look at this and we say, you know what? Since there are no restrictions, we say that on x and y, then we say that the domain is x is all reals, and the range is y is all reals. Now, the question is, by looking at a graph, how can we tell the domain and the range? So we know that graphs of functions are continuous data. That's the idea, because like every single little x value, as long as there's no discontinuities, for example, a line or a parabola, every single x value goes to a y value. So this the idea is continuous. The question is, how do we figure out the range and the domain of a graph? And so the idea is, first, look at the picture. Look at the graph from left to right. Literally see where the x's start, and then see where they stop. Next, look at the graph from down to up. Let's see, down or bottom to top. We'll go from that. Bottom to top. So you're going to start at the bottom, and then you're going to go up, and then see where it stops. Maybe there's a jump, but the idea is it just keeps going up. Maybe it stops, or maybe it starts. See where it starts, see where it stops. And then you're going to express the domain. So for example, so the idea, okay, so, sorry about that. So the idea is, here's the problem in the book. Take a snapshot, please. Good. So the idea is, as I move from left to right, where does it start? Well, it starts at 5. Starts at -5, and it just goes to infinity. The question is, you might say, oh, well, it seems to like stop at 5. No. The arrow, it just keeps going. It just keeps going that direction. It keeps going. You actually might argue in a more advanced class that it does stop at 5. It seems to be like not getting close to 5, or it seems to approach. It starts at 5 and seems to approach 5. Kind of interesting. What's going on with the range? Well, I start at the top, I start at the bottom, and I go up. Well, the bottom seems to come up from it. So from the bottom, it starts at -infinity, and then just kind of stops, right? It kind of just stops at 5, and then stops at 5. So what do you think? How can we write this as 2 inequalities? Well, for this, let's talk about the domain. Well, it started at 5, and it kind of like moved towards 5, but it never got there. And then for the range, well, it started at -infinity, and it started at -infinity. And just stopped at 5. And so this is 2 ways we can write the domain and the range, or we can say -5 is less than or equal to x is less than 5, and the range is simply x is less than 5 or equal to 5. These are 2 ways. Let's move on. And there's a couple of examples in the book. So for example, in the first example, there seems to be a parabola that has a max at 6. So the question is, what is the domain? What is the range? Well, we know that the domain is all x values are real, because we know from a parabola, we kind of know the equation of that parabola. But we know that we can stick x values infinitely. The problem is, what's the range? Well, the range is y is less than or equal to 6. We start at 6, it just goes down to negative infinity. Next example, how about a line? Well, we look at this line, we know lines, we can stick any x value and we can stick any y value in. So the domain is x is all reals, and we know the range is y is all reals. Example C. Example C is known as a sine wave. Now, you might say, hey, Mr. Riley, the arrows are like going up. No. It continues the the arrows continue the pattern. The arrows continue the pattern. And so I'm telling you that it kind of like there's a maximum of 2. So we say the domain is x is all the reals, but the range, you notice that it reaches the max of 2 and the minimum of negative 2. We'll be studying this in the trigonometry chapter. And then the last thing we want to look at is this. This is known as a rational function. I'm sorry, I wrote it wrong. This is a rational function, and it actually, I'll tell you the equation. This has the equation of y equals the square root of x minus 2. Now, y equals the square root of x, and then it's 2 to the right. We'll be studying that in the transformations chapter. What's going on here? Well, let's see. It's clearly that if this is 2, just by looking at this, we know that the domain is x is greater than or equal to 2, and the range is, well, we know that we cannot have, this is always going to be a positive number, so the y is greater than or equal to 0. And in the next unit, we'll be talking about exactly what we can put in here. Last question. And then we're done. But domain and range. The question is, the path of the golf ball after being hit by a club is modeled h of t is equal to 60t minus 16.1 t squared, where t is the seconds after hit, and then h of t is the height. And so, number one, they want you to take your GDC, and they want you to, just sketch a graph of, so you put this in your GDC. You know that we're only interested in t is greater than or equal to 0. Who cares about -1? We're not interested in that because it's a real world problem. We can see that from the GDC. It starts at 0. We know as math students this is a parabola, and then it comes back down. Now, because we have our GDC, we're able to figure out what do they want us to do. They want us to, okay, well, first of all, is this a function? Is it a function? So think about it. Yes, it's a function because it is a function because it passes the vertical line test. Good. Next thing they want to know the t-intercepts and the maximum value. Use your GDC to find that. Okay. T equals 0. T equals 3.73. And the maximum is, what do we got? 55.9. And therefore they want to know what is the domain and what is the range. Okay, so the domain, what do you think? Good. It's from 0 to t, 3.73. Are we interested in anything? We're not interested in the negative numbers. We don't care about any of the time after 3.73 because it came to the ground. There's nothing else it can do. And then the range, what are the possible range values? The range is, well, it's from 0 to 55.9. And so it's interesting. I could ask you, where is it at a specific time? Or I can say, what is the time at a specific height? Nice. Good.